Alright, let's dive into something powerful. A real superpower in the world of data. We're talking about regression, the engine behind almost every prediction you can imagine. And trust me, by the end of this, you'll start seeing it everywhere. So it all boils down to one huge question. How can we use what's already happened to predict what's going to happen? Whether you're exploring business trends, scientific outcomes, just plain curious, this is the big puzzle we're solving. And the answer, of course, is regression. At its heart, regression is simply a clever way of finding the mathematical link between different variables. Think of it as connecting the dots. You have data everywhere, and regression helps you draw the line through it, revealing the hidden pattern. That pattern becomes our crystal ball. Now, where do we begin? We start at the absolute foundation. The simplest, most elegant idea of all is straight line. Seriously, this is the bedrock of nearly every regression model. Here's the equation. It may look a bit math heavy, but don't worry. This simple formula is the engine that makes it all work. The recipe for that straight line we just mentioned. Let's break it down piece by piece. Y is what we want to predict, say, your exam score. X is what we already know, maybe the hours you studied. Day or beta 0 is the starting point, the score you'd get if you studied 0 hours. But 2 or beta 1 is the slope. It tells us for every extra hour you study, how much higher your score might go. And that little d epsilon represents the random stuff we can't control, your mood, tricky questions, or sheer luck. Pretty cool, right? Life isn't always that simple. What happens when the relationship isn't a perfect straight line? You guessed it. Time to expand our toolkit. Most real-world data is messy. On the left, we've got linear regression, perfect for consistent trends. On the right, polynomial regression, built for when things curve. Think about population growth. It starts slow, then suddenly booms. Polynomial regression lets our model bend and flex to capture those complex patterns. But wait, what about when many factors work together? That's where multiple linear regression steps in. Picture predicting a house price. It's not just about square footage. It's bedrooms, neighborhood, roof age, all of it. Multiple regression lets us combine all those inputs to get one far more accurate prediction. Now that we've built these powerful models, how do we know they're any good? A prediction is useless if we can't measure its accuracy. That's where residuals come in. A residual is simply the gap between what actually happened and what our line predicted. The tiny bit of error for each point. The best fit line is the one that makes the total of all those errors as small as possible. To measure this, we use metrics, kind of like a report card for our model. There's R squared, which tells us how much variation our model explains, and measures like RMSE or MEME, which show how far off our predictions are on average. So a high R squared and low error numbers mean a great model. Alright, now we know how it works and how to grade it. But why does any of this matter? Because regression is everywhere. In finance, models predict stock prices from past performance, market trends, and big news. In business, it powers sales forecasting, helping companies plan inventory and marketing. In science, it drives climate models, mapping CO levels, temperature, and melting ice. Even in medicine, regression predicts recovery time using age, surgery type, and other health factors. Pretty much anywhere you see a trend being analyzed or a prediction being made, regression is quietly working behind the scenes. It's the invisible engine of our modern world. So now that you know the secret, look at your own life, your work, your hobbies. What hidden patterns can you find? And if you could, what would you predict?